Alright, so for this particular video, we're going to be talking about, first, principles. Now, what is first principles? Well, back before we had all these shortcuts to finding the derivative of any curve algebraically, we were just trying to find out, and by we I mean the founders of calculus like Gottfried Leibniz and Sir Isaac Newton. We were trying to find out, okay, let's say we have a function of x equals to x squared plus 2x plus 2. Sorry about that. And let's say we didn't know the graph. I mean, actually, they had graphing capabilities back then. Let's say it's over along here. That's the graph of that function. Now let's say that, okay, graphing all of the particular slopes of the tangent lines is too tedious for us. How about we just imagine a point at x, f of x. And now let's imagine another point, appropriately x plus h, because, you know, it's h more of this x at that particular function. And appropriately, the x value is going to be fx plus h. And we draw a line to that. Okay, now exactly the tangent line, it's the line between 2 points of the function. But let's say to get the tangent line at that particular point, and hence all points, to get the tangent line, we just make h become smaller. So let's set that from here to here. Smaller and smaller and smaller and smaller and smaller until we finally get the slope at the tangent line. So in this case, h, which is the distance between our x value and our supposedly other point, h is going to become so small that it's going to tend to 0. It's going to eventually approach 0. So the slope, just like any slope, the slope at that particular the slope of the tangent line is just going to be, well, just like any other slope. You have y2 minus y1 all over x2 minus x1. But we really, or if you so desire, the change in y over the change in x. Now, let's turn to the next page. Now, in this case, we already know what delta x is. It's h, because that is the distance between x and the value and the other value of x that we're reaching. And delta y is going to be equal to y2 minus y1, and which is appropriately fx plus h minus f of x. And we know that for the slope of the tangent line, h is going to tend to 0. In this case, we say at the limit as h approaches 0. Because eventually, h tending to 0 will approach a limit. So in total, if we put that all together, we get the derivative of the function of that we just drew, which is x squared plus 2x plus 2, it's going to be equal to, as the limit approaches h, as the limit of h approaches 0, it's going to be f x plus h minus f of x all over h. And that is just first principles. That's just logically what a derivative is. It's simply finding the slope of the tangent line at a particular point x, or in this case, all points of the graph x, and just slowly but surely getting the 2 points closer and closer and closer and closer until you just find the slope of the tangent line via this particular instance, this particular formula. So let's actually solve what we had before. So we had our function f of x equals x squared plus 2x plus 2. Now let's, what's fx plus h? Well, we can do that. We can just substitute x for x plus h squared plus 2x plus h plus 2. And simplifying that, we have x squared. We're doing FOIL over here. X squared plus 2xh plus h squared. And substitute, I'm actually using the distributive property. We multiply that, we get plus 2x plus 2h plus 2. Now let's put that all together in our handy dandy formula. Derivative of x f of x is equal to, as the limit of h approaches 0, is going to be equal to fx plus h, x squared plus 2xh plus h squared. Ooh, I might need more paper for this actually. But don't worry, we've got plenty of paper. Gee, let's put it all to long form here. It's equal to limit as h approaches 0. My lines aren't so straight, but that's alright. X squared plus 2xh plus h squared plus 2x. Sometimes, you know, when mathematicians, we get all whispery because we like what we do. And minus f of x, which can be x squared minus x squared plus 2x plus 2 all over h. Well, subtracting like terms, we can subtract x squared on both sides. Subtract this and this, subtract this and this, and we get 2x h plus h squared plus 2h all over h. And of course, sorry, the limit as h equals 0. No, sorry, I'm sorry. We have budget constraints, but that's alright. Budget can't overcome learning. And we simply factor out the h. 2h plus h, 2x plus h plus 2 all over h. Cross out the h. And we get the derivative of the function we had previously is going to be 2x plus 2, because h approaches 0, so all the h's go to 0. And that's how, through first principles, we get our derivative. Isn't that nice? Next video we're talking about rules of calculus, like rules of differential calculus, and how to make this whole process much quicker. Au revoir.